Hi, so I'm Yunro. I'm the tech lead of form.gov.sg. Today I want to talk about what I see is quite important for future engineering development work on OGP, given that we're increasingly building more and more mission critical systems. And one of the ways that as developers we can deliver systems that are more reliable and robust is to encourage safer coding practices. So Typesafe is a product that actually helps developers as they write code, um, help them to avoid the pitfalls in JavaScript and TypeScript, which is the language that most of us on the team use. Right. So let me just get into it. As you all know, as users, one of the most disappointing things that you can see when you try to visit a website or government service is that the service is down. So normally what happens is that you get served a page like a 504 gateway timeout, and there's literally no error message telling you why the service is down. Even worse, if you're not using a service such as Cloudflare, you simply get this site can't be reached. Right. So how does it work is that Typesafe is actually a linting plugin, which is a fancy way of saying that it's a library that if you install, we will try and encourage you to move towards in a direction where your code can be automatically checked by the compiler that you're using when writing code. So let me try and explain the inspiration behind this hackathon project, right? So imagine like you as a developer, you need to write very convoluted logic, and you need to like write these if-else statements and all these like business logic that you want to encode into your program in a server to deliver a service. Now the problem is that sometimes the logic that you have to write is actually convoluted, and they accept user input, and if the input is malicious or even not malicious, but because of sheer oversight, that your server can crash, right? So say for example, you're writing a simple function here called divide, and divide takes two numbers, A and B, and it returns another number, right? And the function is extremely simple. But what if somewhere in your program, because of user input, you call divide and the divisor is 0? So what's going to happen is, in many programming languages, your server is going to crash immediately. In JavaScript, however, you get this quirk where you return a special value called infinity. And if you ever get an infinity in your program, that's it. Everything else you do is just going to be bugs downstream. So what a lot of developers do is that they put in these error checking conditions. They say that, okay, if I'm trying to do a math operation, say division, if the divisor is 0, I will throw an error, and I say there's an error called division by 0. Now, someone else could have written this code, and when another developer tries to call this function divide, what's going to happen is that they might not know that this function could be throwing an error, and you end up again with your server crashing because the error wasn't handled properly. In this case, if you call divide with error and you divide by 0, you get an uncalled error, and your program terminates immediately, your server crashes immediately. So how the format is approaching this is that we never throw an error in the program. We always return them as a value. So previously, when you look at the code divide or divide with error, you see that it returns a type number. But here, if you do it in the more type-safe way, what you do is that you return either a number or an error. And so when you try and use it simply as a number, the TypeScript compiler will warn you and say, okay, you cannot apply the addition operation to a type of number or error because it could be either. You can only apply it to a number. So immediately this sets off the developer saying, okay, this isn't workable. I need to check whether or not an error could be coming back, right? And so the better code to do is to actually check, okay, if there's an instance of error, it's not an instance of error, I will add 1 to my number because that's what I need to do for my job. Otherwise, I will log the message, right? So there will be error handling inbuilt because of type safety. Yeah. So this linting rule in the program to discourage developers from throwing errors is called no throw for synchronous functions. Essentially, what you do is that the moment that developer types throw a new error, this warning message shows up to say you should be returning an error instead of throwing it. And similarly, if you need to fetch external data, and let's say the service you're calling is unreliable, it fails 10% of the time, what we do is we also have two linting rules that will help the developer catch a mistake. So in this case, what the code is doing here is trying to fetch external data and apply 10 to it. But you notice that there's a section of external data could fail. And so the linting rules will come in and say, okay, you should use a try catch block here to make sure that you account for the case that external data set would fail. And similarly, when you try multiply data by 10, because it relies on the section of external data, that you also need to handle that statement. So we have actually shipped this code to format S3, and we're using it in production. We use it in as a.
Your time is up.
Oh, okay. Thanks very much for listening. But yeah, hopefully this makes sense, and happy to answer any questions.